In this first teaching unit, we will give an introduction to geographic information systems. In this unit, we will explore the following topics. What is a GIS? What solutions can we get with GIS? What are its basic components? What are its functions? What kind of data can be loaded, stored, analyzed within a GIS? And what are the different programs and organizations who use these programs? We will begin with a definition to what is a GIS. Geographic Information Systems is an information system capable of integrating, storing, editing, analyzing, sharing, and displaying geographically referenced information. Therefore, displaying georeferenced data in the territory. It is a tool with which users can make interactive queries, searches and user-defined filters, and to analyze spatial information which can be edited, as we will see later on. What questions can be answered with a GIS? Well, localization issues. What is this place, condition? Where does it happen to be? Trend changes in this area of territory. Route. What is the optimal way to get in this place? Guidelines. What guidelines exist on this particular subject? Or model what will happen if we change this data, analyze information, and so on. Which are the basic components of this system? Well, the hardware, the machinery we use to host the program, the software. This could be open source. Also, we have the processes that use the software. We have also the people using the data. People have to be very trained to use the data and make concrete analysis and have full assurance of what they are doing. And finally, a very important point is the data. Having good data is vital for the analysis and for optimal conclusions. What functionalities does a geographic information system have? Well, just to list them here, we can capture, store, query, analyze, visualize, and state all this geodata reference to terrain. Capturing data. Whether we have to georeference using printed maps or digital data or an XY coordinate file via mobile devices, GIS is a technology that evolves very fast and allows us to use it in situ in order to collect all the necessary data for our work. This means that we can take our mobile device, which we have installed our GIS system on it, and collect the data we need when we are collecting information in field. Another feature of GIS is storing data. We'll see over the course these formats, the vector format and the raster format. The vector format is that we have well-defined points with coordinates or lines or polygons. A raster format is a format where continuous data is divided by cells. The definition depends on the pixel size of this cell, and it will have a value in each of the cells, storing only one value for each pixel. Consulting data. This can be done with the different tools that GIS programs have. Once the data has been on screen, we can identify an item and display that data attributed to this item. This can also be done with queries or filters, generally taking into account a specific query. Another functionality is to analyze data. We could make a proximity analysis, for example. If we want to check the population of residential areas around a river for approximately a radius of 5 kilometers, we could check this with queries. There are different types of analysis which can be performed. We could analyze water networks such as urban drainage, sewerage networks, or road routes, i.e. urban infrastructure. We could also visualize GIS data. Much of our work is focused to visualize maps via the program interface to see the geoposition graphic elements, but can also obtain graphs, reports, data that we have loaded on our GIS. And finally, we will see the output data of our GIS. Either through maps we can print, either by extracting a specific image for a quick job, either by publishing this data to the internet on a web map service, generating documents and reports of different alphanumeric data we have stored on our project. Before, we spoke about the type of data we can store in a GIS. Well, we have vectors and raster formats. The vector format is defined by points, lines, or polygons. The raster format is a format with continuous information where it is divided by cells with a particular value. Within the vector formats, we have the best known, the shapefile format that was released by GS3, which is composed by several files. It is what we will use throughout the course. Other formats include ArcInfo coverage format, Geodatabase, KML, and GPX. And now for raster formats. We have ArcInfo Grid, ASC2, which are text files, image files, or orthophotos in TIF, IPG, PMP format with a georeferencing file such as TFW, World, JGW, or BPW. One of the most important issues when working with the data in a GIS is the coordinate reference system, the coordinate reference system in which we are working. GIS programs enables us to work both with geographic coordinate systems, i.e. with latitude and longitude, or projected coordinate systems such as Cartesian coordinates in X, Y, and within projected coordinates, we need to know the datum we are working in. This will be discussed later, but it is important to know which is the appropriate coordinate system to work with. Within the nature of the data stored on a GIS, we have three components of geographic data: spatial, thematic, and temporary. Within the data quality, we attach positional accuracy, thematic accuracy, logical consistency, and timing of the data. Depending on the data you are working, we require positional accuracy. Or if we are working with information that varies in time, we need temporality of such data. Here we have a list of different GIS programs, both open source and proprietary ones. These ones include map servers, geoservers, and all the other programs at our disposal. And listing of some of the entities using geographic information systems, we can see administrations and municipalities, county councils, local economic departments, for environmental issues, agriculture, cultural issues, political and territorial company services, for drinking water, providing consulting services to other companies or organizations. Here we have some examples where they use geographic information systems in potential areas. We are now at the end of this teaching unit to the introduction of geographic information systems.